requiring state-of-the-art security, carefully monitored temperature and pressure conditions, and 3 separate keys to access. It stores what could be considered as Holy Grail, a small and shiny metal cylinder called the International Prototype Kilogram, IPK, or in French, Le Grand K. A physical absolute gold standard of what 1 kilogram means on Earth. It's the only one of its kind, but several copies of it have been created, calibrated, and sent out to the countries all over the globe. And countries use these copies to create their respective scale weights. You lose one of these scale weights, you could always buy another one. But if you lose the IPK, and the world crumbles down to chaos. But on 17th November 2018, at the 26th General Conference of Weights and Measures, all the participating countries voted to stop using any physical standard like the Grand K and redefine all base physical quantities in terms of abstract universal constants. And a direct result of this event, Le Grand K, or the K now, became yet another bookmark in our glorious history. But more importantly, 1 kilogram was no longer defined as some metal cylinder, but rather in terms of a universal constant called Planck's constant. For someone who is working in an advanced physical laboratory, that might make a lot of sense. But for someone like you, like me, a layman, forget it. What is Planck's constant? Personally speaking, I even had a problem with changing the definition at the first place. As soon as I read the news, I was like, if the definition has been fine since 1889, why bother to change? Why change when practically every human being on this planet has accepted the older definition? Turns out, the IPK, since its creation, has been losing weight. Lucky IPK. Over every single year. By 2018, the loss was somewhere around 50 micrograms. What is that? Like the weight of one eyelash? Who cares? Maybe we don't. For laymen like us, it is not that significant. It is absolutely not significant. But if you start thinking about advanced medical applications or any field which requires fine calculations, this number, trust me, is huge. Moreover, remember what the IPK represented? The gold standard of a kilogram. Something that should not change over time or place. And if it starts losing weight, it sort of defeats the purpose. Okay, so that explains why we stopped using the IPK. But if the end goal was to have a standard, couldn't they have made a new cylinder? A new IPK? I mean, if the old cylinder lost its weight, why not replace it with a new one with the required shape, required size, and maybe a better material that does not lose weight? You know what? I really wish I can answer that question in one line. Okay, let me try. A standardized unit needs to be invariant across time and space, easily accessible, reproducible, and accurate to the highest of degrees. And since everything around us inevitably goes through change, we need to base our references on stronger marks, which do not change across the dimension. Ergo, therefore, hence, Planck's constant and not a new cylinder. That was definitely not one line and not simple. And I bet you did not understand a single word that I said. Not your fault, honestly. Because that explanation only makes sense when we already have a grasp of what is a unit, how did we start using them, How did we come across things like IPK? And finally, how do we choose to make a standard? And the answers to all of these questions lies in our history, our own history of measurement. The discovery of fire catapulted the mankind from age of stone to age of metal. And then, with the help of invention of the wheel, from mere consumers, we became producers. In a way, this wheel set the path rolling. And all this while, these little clay tokens were creating a history of their own. You see, these tokens belong to one of the oldest civilization on earth residing in Tepe Gaura, present-day Iraq, around 4000 BC. Mankind by then had moved on from hunting and residing in caves to agriculture and food production. And as it turns out, as mankind started doing agriculture, a system was needed to track quantities of the produce. They needed a system which answers the questions: how many sheep do I have? How much cereal have I produced? For how much cereal of mine can I get some milk from my neighbor? What they needed was a system which tells them how much and of what type. What they needed was a system of measurement. And these tokens were base references, or as we call them formally today, units of measurement. Now, before any of you start thinking, what? A token is a unit? Isn't unit supposed to be a fancy name like kilogram, kilometer, degree Celsius? Let me show you. Focus on the idea behind creating a unit to keep track of things and to measure them. A simple system. Assign a unique token to a certain amount of certain something. This token would then work sort of like a base reference or unit measurement for that certain something. And all higher measurements could be expressed in terms of multiples of this unit. Let me show you how that works. Say we are the settlers of that era and we want to create a system of measurement for water. Now we can't count water, can we? Because, water. So here is a solution. Let's take this clay pot and one of different size, maybe this one. I don't know how to express the amount of water in this clay pot or in this one. So let me assign token A and token B. What token A and token B represent, express, is the amount of water held by clay pot 1 and clay pot 2. Let's devise a simple experiment to substantiate this. Let's say I have to measure the amount of water this bottle is holding using the tokens I established. What do we do? Use them. Okay, some water is still left. So let me put that water in this pot. Some water is still left. So I have to take one more pot. Let's take the smaller one. And right. Okay. What just happened? What you have is one token A pot full of water and two token B pots full of water. The summary of this experiment is that we are just able to express the amount of water in the bottle in terms of established units. This bottle is holding token A plus 2 token B worth of water. And that's how token works as a unit. Yes, a system like this has many flaws. Like we can't really measure an amount of water smaller than the fixed size of the bowl. Or somebody else could have bowls of different size and shape other than the base we set, like this one. Or their measurement could be different from us. Or somebody could have an entirely different set of tokens for the same measurement system. But what it does set up for the future is the idea of what is a unit. A unit is nothing but a base accepted reference for measuring something. The early Stone Age system of units consisted of tokens, which were explicitly used for measuring amounts, or let's say volume. But as agriculture flourished, civilizations were formed along the banks of the rivers. And with civilizations came societal structure and organization. We started building places to stay, places to worship, places to trade, places to pay homage. And building those places needed similar units for measuring length, area, mass, and time. And these units had to be standardized so that whoever uses, whenever someone uses, and wherever someone uses the units should yield exactly the same result. Mark my words very carefully. Whoever uses, whenever someone uses, and wherever someone uses. The three criteria which we just established make a unit standardized for usage. And as the need arose, we thought of the most common element of nature available to standardize our unit. Us. The idea of using the human body to standardize units gained so much popularity that even today we frequently use some of them. What? We use us, my foot. You get the reference. Well, how do you express your height? Although the exact origin of units, foot and inches remain ambiguous, multiple records suggest that these units did indeed start off based on human body proportions. The ancient Roman sculpture's foot length was what was considered to be a standard for one Roman foot. They also took it one step further by subdividing into 12 unciae. Copies of metal based on this foot measuring, 1 foot and unciae, were then created and distributed among masses for their usage. The Roman Empire faded to history around 476 AD, but it did have a strong legacy behind. Unciae eventually led to the English word inch. And guess what? Even today, we equate 12 inches to 1 foot. Standardized units based on human body proportions. Remind me, what were the criteria for a standard again? Can everyone